Hi everyone, I'm Dr. Garcia, and welcome to our course, Thermodynamics.
The word thermodynamics is derived from two Greek words thermos, meaning heat, and dynamikos, meaning power. Thermodynamics is the study of heat and its transformation into work. Thermodynamics is the field of physics that deals with the relationship between heat and other properties, such as pressure, density, temperature, etc. in a substance. Specifically, thermodynamics focuses largely on how a heat transfer is related to various energy changes within a physical system undergoing a thermodynamic process. Such processes usually result in work being done by the system and are guided by the laws of thermodynamics. It was James Prescott Joule who demonstrated that the quantity of work necessary to cause a given change of state is independent of the type of work, the method of delivering, or the rate of doing work. He also concluded that work could be converted into heat and heat into work. Since then, thermodynamics provides the basic theories in constructing heat engines, steam engines, to the basic theory of refrigerators and heat pumps. From previous units, you have learned that energy is needed to perform work. When work is done on a body, energy is transferred to that body. The transfer of energy to the body increases the internal energy. The internal will later decrease as the body converts it to heat. From Joule's theory, the reverse should also be true. Energy can be converted or transferred to a body as heat, and the body can perform work. Consider the hot air balloon in figure 3.1. Energy is transferred as heat from the flame of the burner to the air inside the balloon. The air inside increases its internal energy, and as a result, the volume of the air inside also increases. This expansion of the air inside provides a force against the inside surface of the balloon and inflates it. As a consequence, the hot air does work on the balloon, and doing work will decrease the internal energy of the hot air, thus conserving energy. From this example, the work done by the hot air comes from the heat that was supplied by the flame. The work done on or by the hot air or gas in general produces pressure and changes the volume of the balloon. When a certain volume of gas expands, it works against external pressure to expand. That is, the gas must perform work. Assuming that the external pressure is constant, by the simplest description of work in a thermodynamic setting, work is the product of the pressure applied on or by the gas and change in volume. We have the equation work is equals to P multiplied by delta V, where P is equals to pressure, F is equals to force, A is equals to the cross-sectional area of the cylinder, delta D is equals to the change in distance, and delta V is the change in volume. Volume changes are usually expressed in liters, while pressures are usually expressed in atmospheres. When we use the equation to determine work, the unit for work derives out as liter atmospheres or LATM. This is not a very common unit for work. However, there is a conversion factor between liter atmosphere and the common unit of work, joules. 1 liter atmosphere is equals to 101.32 joules. So let us give an example. A cylindrical container with a cross-sectional area of 0.020 meters square and a movable piston contains a certain amount of gas. If the gas exerts a constant pressure of 2.5 times 10 raised to 5 Pascal, causing the piston to move 0.015 meters, how much work was done by the expanding gas? From the problem, we have the following given. The area is 0.020 meters square. For the pressure, it is equals to 2.5 times 10 raised to 5 Pascal, and the change in distance is 0.050 meters. So we are asked to find the work. Using the formula for work is equals to P multiplied by delta V. We have the following solution. 2.5 times 10 raised to 5 Pascal multiplied by 0.020 meter square multiplied by 0.050 meter. The answer for work is 2.5 times 10 raised to 2 joules. The Pascal is an SI derived unit of pressure. It is equivalent to joules per meter cube. Now let us proceed to another example. What is the work performed by gas if it expands from 3.44 liters to 6.19 liters against an external pressure of 1.26 atmosphere? Express the final answer in joules. So from the problem, we have the following given. Pressure is equals to 1.26 atmosphere. The initial volume is 3.44 liters and the final volume is 6.19 liters. So we are asked to find the work. So we're going to use the equation for work, wherein work is equals to negative P multiplied by the change in V. So substituting the following given, we have negative 1.26 atmosphere multiplied by the change in volume 6.19 liters minus 3.44 liters is equals to negative 3.465 liter atmosphere or negative 351 joules. The negative sign in the equation for work is important and implies that as volume expands, the gas in the system is losing energy as work. On the other hand, if the gas is contracting, change in V is negative, and the two negative signs make the work positive, so energy is being added to the system. That's all from now. Thank you and keep safe.